Hello and welcome back. This is a video over section P6, and we're going to be talking about rational expressions. Now remember that a rational expression is simply a fraction, okay? And remember, guys, fractions are your friends, okay? They're not going to, they're always going to be there on a Friday night to hang out, okay? That's the good thing about fractions, okay? They're always going to be there to help you. So, the root word in rational is ratio, okay? And that means essentially a fraction. So, I want to talk about a couple of properties of fractions. The first part is you have a numerator and you have a denominator, okay? And this is essentially your fraction, okay? The one key component about the denominator, and this is extremely important, is that the denominator cannot be 0. Okay, that is really, really, really important. If the denominator is 0, you can't divide by 0. Okay, so let's write that. You can't divide by 0. Okay, if the denominator is 0, comma, then the value is undefined, okay? And we'll talk about that here in a second on the first couple of problems, but I want to talk about operations with fractions, okay? So we have operations with fractions, okay? The first thing I want to do is simplify a fraction, okay? And what I would do to simplify a fraction is this. Let's just say I have the fraction, 6 over 8, okay? One of the things that we can do is we can divide each of these numbers by 2, okay? And if I divide each of those numbers by 2, what ends up happening is I get 6 divided by 2, which is 3, and 8 divided by 2, which is 4. And there's no other number that I can divide into the numerator or denominator, okay? And that's what we get here, okay? This is one way to think about it. Another way is to factor. So simplify by factoring, okay? And I'm just going to use numbers because we'll have examples with algebraic expressions here in a second. But let's take that same thing, 6 over 8. Now what I can do is I could factor the number 6 and I could factor the number 8. And each of those contain a factor of 2. Hence the whole idea of dividing each of these by 2. Okay, so you can think of it another way. You could rewrite it as 3 times 2 divided by 4 times 2. Now what happens here is I want to look at this value here, 2 divided by 2. And 2 divided by 2 essentially divides out to 1, okay? And so what you are left with then is just 3/4, okay? Let me use black. So we get 3/4. Okay, so kind of a couple different ways of doing it. All right, so that's something that we'll need to be able to do. And let's kind of talk about a little bit of some of these nuances that we have with fractions. Now, the first operation that we can do is we can multiply fractions. Okay, and multiplying fractions, we just multiply across. So multiply across. Maybe that's just 1C, I'm not really sure. That's why I'm a math teacher, not an English teacher, guys. All right, so if I multiply across, what I want to do is this. So like, let's say I have 2/3 times, 4/5, okay? What I would do, if I'm multiplying these, I just want to multiply them across. So I'm going to do 2 times 4, Okay, that's going to go in my numerator, and then I'm going to do 3 times 5. Okay, And what I'm going to get there, I can combine that as one fraction, and I'm going to get 8 over 15. Okay, now unfortunately, there is no number that divides 8 and 15. Okay, so this is already simplified. Okay, but if we wanted to simplify it like we did up in these examples, we can. All right, now let's talk about division. Okay, and we'll talk more about all these operations here in a minute. But division, what I want to do is, let's say I take 2/3 and divide it by, what was that number? What do we do? 4/5? Okay, divide by 4/5. Okay, so when we do division, we want to multiply by the reciprocal. Okay, and what that means, when we multiply the reciprocal, that means that we flip the fraction. Okay, well, hold on. The reciprocal means we flip the fraction. Okay. So what I want to do here, all right, my next step, if I were to do this, I would do 2/3 times 5/4. Okay. And then I would simply just multiply across, and that would give me 2 times 5 divided by 3 times 4. Now what we get as a result, 2 times 5, that's going to give me 10 over 12. Now each of these, are divisible by 2. Okay, so I can divide 2 by each of these, and that would give me 5/6. Okay, so, pretty simple, things that you've done before. Probably need a little bit of a refresher. Let's do adding and subtracting. Okay. So we have addition. Okay. And we just need common denominators. All right. So I'm going to do this. I'm going to do, say 1/2 plus 3/4. Okay. And so since I don't have common denominators, what I have to do is I have to turn one of the denominators into the other one, if you can. So, and we have to use multiplication. So what I know about this is that 2, I can multiply 2 by 2, all right, to get 4, all right? And I have to do to the top and the bottom. Okay, so what I'm going to get as a result is this. I'm going to get 2. So now I have 2, now I'm multiplying. So I have 2 times 1, which gives me 2. 2 times 2, which gives me 4. And then add that to 3/4. And once I have that, then what I can do is I can then just do 2 plus 3 all over 4. Okay, so once I have that common denominator, which is right here, 4 and 4, I just add my numerators. Okay, and what that's going to give me is that's going to give me 5/4. Okay, and that's the idea. Now let's say we have another one, and addition and subtraction work the same way. You just need a common denominator. And so let's do this. Let's say I have 1/2 minus 1/3. Okay, now the issue with this one is that 2 and 3, I can't multiply 2 by anything to give me 3. Okay, so what I would need to do is need to think about common multiples of 2 and 3. Now, what I can think of is that those would just be 6. So I would multiply, the trick is to multiply this one by 3 over 3, and this one by 2 over 2. Okay, so if you multiply this fraction 1/2 by the opposite denominator, and vice versa, multiply this fraction by this opposite denominator, okay, you'll get a common denominator. All right, so what this would end up giving me would be 3/6 minus 2/6. And then what I would do, subtraction works the same way. I just need a common denominator. So I would put this all over 6, and I would do 3 minus 2 over 6, and that would just give me 1/6. Okay, so that's essentially how we operate with fractions. Now what we need to do is we need to make this jump over to doing these types of things. Okay, so this is kind of the overarching, big concepts, guys. And make sure you write small. Sorry that I'm probably going off the page a little bit, but let's just jump right in here and work on some of these examples. Okay, so on this first one, it says find all the numbers that must be excluded from the domain of each rational expression. Okay, so remember up here where I talked about how the denominator can't be 0? Okay, how we can't divide by 0? If the denominator is 0, then the value is undefined. Okay, so we have these expressions here, all right? And I could plug in any number for x except for 1. And there is a number that will make this denominator 0. And what I do is this. I take my denominator, which is x plus 5, and I set it equal to 0 and solve for x. Okay? So what I'm going to do is I'm going to do this. I'm going to plug this, or I'm going to solve for x, so subtract 5 from both sides, and that goes away, and so I get x is equal to -5. Okay? This value here makes my expression undefined. So this value makes the expression undefined. Okay? And so what we have here, find all numbers that must be excluded from the domain of each rational expression. So my domain of this function, and domain is where you have x values, my domain would be all real numbers except x cannot equal -5. Because if I plug in -5, and let's just think about this. All right, we just have an expression here. I have 7 over -5 plus 5. Okay? If I plug that in, what I get is this. I get 7 over -5 plus 5, which is 0. That will make my denominator 0, okay, if I plug that in. All right, otherwise, I could plug in any other number into that expression and we'll get another value, okay? So that's the idea is how you want to figure those out. So final numbers that must be excluded from the domain of each rational expression, and all you do is set your denominator equal to 0 and solve for x, okay? So let's take a look at part B. Now B is x divided by x squared minus 36. Now what I want to do here, all right, is take x squared minus 36 and set that equal to 0. Now we could do this a number of ways. Now what I'm going to do is this. I'm going to add 36 to both sides. Okay, and I'm going to get that x squared is equal to 36. I'm going to take the square root of both sides. Now when I apply the square root like that, I'm going to get that x is equal to plus or minus 6. So my domain would be all real numbers except x cannot equal plus or minus 6. And that's your answer, okay? And that's all we're doing, okay? All right, let's take a look at part C. Now in part C, all right, let's zoom in on this guy. All right, now if I take my denominator here, and this one's a little bit trickier, okay? I want to take my denominator, x squared minus 5x minus 14, and set that equal to 0. Now the issue is that all the other problems were pretty straightforward on how to solve for x. This is a trinomial. If I'm solving this equation for x, the only way that I can do that is by factoring, okay? So what I want to do is factor this. So I'm going to use the box method, okay? And I'm going to put in my first term, x squared, put in my last term, -14, and I'm going to put an x here, okay, so two numbers that multiply to -14 but add to -5 is going to be -7 and +2, okay? So let's just verify. I get -7x. I get +2x. I combine my like terms here, and that's going to give me -5x, which is what we were looking for, so we have factored this correctly. Now, once I have factored this, okay, I write this as x minus 7 times x plus 2 is equal to 0. All right, and I'm going to set each of these factors equal to 0. So I get x minus 7 equals 0, and I get x plus 2 is equal to 0. So I solve for x on each of these, add 7 to both sides. I get x is equal to 7. Okay, here I'm going to subtract 2 from both sides, and I get x is equal to -2. Okay, these are the values that make my denominator 0. So what is that? -2 and +7. So what I would say is that my domain is going to be all real numbers except x equals +7, or x cannot equal 7 and -2. Okay, so that's how we would write that. That's how we want to write our domain. Okay, so pretty straightforward. Now, this is the reason why we need to know how to factor. Because if we know how to factor something, we can solve these equations. It's pretty easy. Okay, next thing I want to do is simplify. Now, what we're going to do is we're going to do this concept of dividing out. We're going to simplify by factoring, kind of like what we did up here, okay, on these next two. So if I wanted to simplify this, okay, I want to see what I can factor out of my numerator and see what I can factor out of my denominator. Now, in my numerator up here, I could factor out a common x squared. So let's do that. All right, I'm going to factor out an x squared, and that's going to leave me with x plus 3. Okay, and then I'm going to divide by x plus 3, okay, which is what I had below. Now, the thing is that you want to realize that I am multiplying each of these, I'm multiplying x squared by this quantity x plus 3, okay? Because I'm multiplying, what I can do is I can divide out the common factor of x plus 3. Now what we're left with is we're left with x squared up top and then a 1 down below, okay? Because x plus 3 divided by x plus 3 is just 1, all right? So even though I just have x squared over 1, I'm just going to write that value as x squared, and this is my simplified version, simplified answer, okay? So remember, and the realization is that this whole thing here and this whole thing here are essentially the same thing. There are a couple bit of differences, but that's the idea that they're the same, okay? Let's take a look at part B. Now, part B, I want to factor my numerator and factor my denominator. Now, if I factor my numerator, all right, I want you to see something. This is difference of squares here, x squared minus 1. So because that's difference of squares, what I can do is I can factor that as x plus 1. And, let me write this up here, okay? This is x plus 1, and this is x minus 1. All right, difference of squares. All right. Now, on this other one, okay, x squared plus 2x plus 1, let's do the box method on that one. So I'm going to put x squared here. I'm going to put a positive 1 here. So x, two numbers that multiply to positive 1 but have to add to positive 2. That's just going to be 1 and 1. So plus 1, plus 1. Okay, so I'm going to get 1x, combine those together. That's going to give me 2x, so we have factored that correctly. So then my denominator factors to x plus 1 times x plus 1. Okay, now what I can do, now that I've factored that, I can divide out the common factors. In my numerator, I see I have an x plus 1, and in my denominator, I see I have an x plus 1. And those are just going to divide out to 1, and then think about what you're left with. You're just left with x minus 1 over x plus 1. And that is my answer. Okay, we're just simplifying. Okay. All right, so factoring is really important. Hopefully you guys see that. All right, now here, when I want to multiply these, okay, it's asking me to multiply these fractions. Now, what I don't want to do is distribute everything and multiply everything out. I want to factor everything first. So on this, when you multiply, factor first. Okay, and then see if anything divides out and then multiply it out. So what I'm going to do is this. I'm going to write out, I've got x plus 3 in my numerator here. X squared minus 4, okay, this part here is difference of squares. I can write that as x plus 2 times x minus 2, okay? Now, up top, over here, x squared minus x minus 6, that's not jumping out at me. Neither is x squared plus 6x plus 9. So what I am going to do is I am going to do the box method on each of those. okay? So I've got x squared and then negative 6. Okay, so I've got x and x, two numbers that are going to multiply to negative 6 but add to negative 1. Let's do minus 3 and then plus 2. Let's just verify that that's right. So I got 2x, I've got negative 3x. Combine my like terms in the middle, and that's going to give me negative x, which is what we were looking for here. So this is good. Okay, let's do the same thing for our denominator here. All right, I'm going to do x squared and then 9. Okay, so x and x. And I want two numbers that are going to multiply to positive 9 but add to 6. That's going to be positive 3 and 3. Okay, so let's just verify. So we get 3x, we get 3x. Add those together. That's going to give me 6x, which is what we were looking for here. Okay, so now here's what I got. All right, let's do this. Let's do, this is going to factor. So let's rewrite that as a factored form. So we've got, what is that, x plus 2 times x minus 3, and then I've got x plus 3 times x plus 3. I don't need to write that that's squared. I mean, you can, but it's not really going to help you that much. So here's what you got. Okay, at this point, I've got x plus 2 can divide out an x plus 2. I've also got that an x plus 3 can divide out one of these x plus 3s. Now, these other ones aren't going to divide out. Okay, you have to have the same quantity in order for them to divide out. So my answer that we're left with, think about what we got. We've got 1 over x minus 2 times x minus 3 over x plus 3. Now, all I'm going to do is just simply multiply across. So in my numerator, I have 1 times the quantity, and these are all quantities. Let me put parentheses around them, okay? I have 1 times x minus 3, which is just x minus 3, divided by x minus 2 times x plus 3. Essentially, we are done here. You can stop here. If you wanted to, multiply out your denominators, you can, okay? But this is okay. This is going to be just fine, all right? So you can just stop there. All right, now let's take a look at the next one. Now, division, let's do something first, okay? Let's change this to multiplication. So I'm going to do this. I'm going to write x squared minus 2x plus 1 divided by x cubed plus x times, I'm going to flip my fraction here, okay? And I'm going to write this as 3x squared plus 3 over x squared plus x minus 2. All right, so first things first, let's factor this numerator over here. Okay, I'm going to do the box method. I've got x squared, I've got positive 1, so x. Now, sorry. So I've got x and x. I want to multiply two numbers that are going to multiply to positive 1, but they need to add to negative 2. So that's going to be negative 1 and negative 1. So negative 1 times negative 1 is going to give me 1. This is negative x, combine my like terms. I get negative 2x. So we're good. Okay, that's how that factors. All right, so let's rewrite this fraction first. Okay, I've got x minus 1 times x minus 1, and then we're going to divide that. What I can factor out here is an x. Okay, so if I factor out an x, I'd be left with x squared plus 1. Okay, we're going to leave that there. All right, so that left side is factored. Let's factor the right side. In my numerator, I could factor out a 3. So and I'd be left with x squared plus 1. All right, and then when I'm doing this, okay, let's factor my denominator here. So I'm going to do the box method here as well. Put x squared and then negative 2. So I've got x, two numbers that are going to multiply to negative 2 but add to 1 would be x minus 1 and x plus 2. Okay, so I'm going to get 2x, I'm going to get negative x, combine like terms, and that's just going to give me an x, which is what we're looking for. Okay, so I'm going to come over here, write out my factors, and do x minus 1, x plus 2. All right, so let's think about what we can divide out. All right, common factors. Now, I can divide out an x minus 1 factor. I could also divide out x squared plus 1 in each of these. So let's think about what you have. You have the quantity x minus 1 over x times 3 over x plus 2. Okay, and let's write it at least as one fraction. Okay, let's write this as 3 times x minus 1 and then x times x plus 2. This would be fine. This is pretty easy to multiply through. Okay, and that would give you 3x minus 3 over x squared plus 2x. And that would be your answer. Either one of these is okay. Okay. All right, so that's the first page on what I want you guys to do. So let's take a look at the next page. Okay, so on the next page, you're being asked to add and subtract these. Okay, and what we're looking for, remember, is we want to have a common denominator. Now, there is a little trick to this one. Okay, and I'm going to zoom in here. I'm going to rewrite this. Okay, I'm going to rewrite this as x over x plus 1 minus, and I'm going to put this in parentheses because this is a quantity, 3x plus 2 over x plus 1. Now, when I do this, okay, I have a common denominator. Okay, I have the same thing in each denominator, so all I need to do is subtract my numerators. Now, I'm going to write this as one fraction. I'm going to write this as x minus the quantity, 3x plus 2, all over x plus 1. Now, when I subtract this quantity, I need to distribute that negative sign, okay? And that's going to give me x minus 3x minus 2 all over x plus 1. All right, and so as a result, what I get is going to be x minus 3x, which is negative 2x, minus 2, all over x plus 1. Now, you may think that you're done, but you're not, because I noticed something here. Is there anything that we could factor out of my numerator? And that would be a negative 2. If I factor out a negative 2, I'm left with x plus 1, which is really interesting because it's the same thing as our denominator. And each of those are factors that can divide out. And so our answer then, guys, is simply the number negative 2. Pretty slick. Okay, so that kind of thing can happen. All right. Let's take a look at the next one. Now, we want to add these together, so we don't have to distribute any negatives. Subtracting fractions can be kind of a pain, but adding them is a little bit easier. Now, here's the deal, okay? We don't have common denominators, okay? X plus 1 and x minus 1 are completely different. Even though you have an x and a 1 in both of them, because one of them is negative, okay, I can't just multiply this one by a negative because then you'd have negative x minus 1. Okay, so what I would want to do in this case, because they're both completely different, and I'm going to rewrite this down here so I got a little bit of room, 3 over x plus 1 plus 5 over x minus 1. Now, I'm going to multiply this entire fraction over here by x minus 1. I'm going to do that in my numerator and my denominator. Now, I'm going to do the same thing on the right side, but I'm going to multiply it by the opposite denominator. Okay? So I've got x plus 1 over x plus 1. Okay? So now, let's think about what you have. All right? What we have now is I've got 3 times x minus 1 over x minus 1 times x plus 1 plus 5 times x plus 1 over x minus 1 times x plus 1. Now, I now have a common denominator here. So all I have to do is add my numerators. Now, I do need to distribute my 3 here and my 5. So let's do that, all right? And I'm going to skip a step. I'm just going to put it all over one fraction. So I'm going to do 3x minus 3. All right, so that's me doing this part here, plus 5x plus 5. That's doing this part. Now I'm going to put that all over a common denominator of x minus 1 times x plus 1. Okay? And then I'm going to combine my like terms. All right, let me move this up here. So I'm going to do combine my like terms of 3x and 5x. That's going to give me 8x. Okay? And then negative 3 plus 5 is going to give me positive 2, so 8x plus 2. And then we're going to divide that by x minus 1 times x plus 1. Okay? And we could factor out a 2 in our numerator and write that as 4x plus 1 over x minus 1 times x plus 1. It doesn't really matter. I will take that. I will take this. If you wanted to even multiply out the denominator, you could do that too. So it kind of just depends on what you want to do. But, that's what I got. All right, so that's how we would do that. All right, let's take a look here. It wants me to find, in this example, find the least common denominator of these two. Okay? And so it basically just wants me to find the common denominator. I'm going to do this. I'm going to do 3 over. I'm going to factor my denominator here. Now, this is going to factor, let me do the box method. I've got x squared, I got positive 9, so x, two numbers that are going to multiply to positive 9 but add to negative 6. So they need to both be negative, so negative 3 and negative 3. Negative 3x, negative 3x, combine like terms. This gives me negative 6x. We're good. So this is going to simplify to x minus 3, x minus 3. Okay, or factor to x minus 3, x minus 3. Okay, now on the other one, notice that this is a difference of squares. Okay, notice how this is x plus 3 and this is x minus 3. Okay, now I want you to notice something. Okay, here are your denominators. So I'm going to write these over here. Denominators. Okay, you have x minus 3, x minus 3. Here you have x plus 3 and x minus 3. Now what you realize is that you need to have, it's kind of hard to explain this, but what you need in this example is you've got 2 x minus 3's, okay, in this one. You only have 1 x minus 3, but I need 2 of them. And then I have an x plus 3 here, but I don't have those here. So if I wanted to get common denominators, okay, between the two to combine them, I would need 2 x minus 3's, okay? So I have x minus 3, okay? And then I would need to have an x plus 3, okay? And that would be the denominator that I would need. Okay, this is my common denominator. So let's do a couple more problems on what that looks like and how we find that. Okay, so let's take a look at this guy here. Okay, on this, okay, let's factor this denominator. And so I have x squared and positive 25. So x and x. If they multiply to positive 25, they need to add to negative 10. So it's going to be negative 5 and negative 5. Okay? So let's verify that works. I got negative 5x, negative 5x. Combine my like terms into negative 10x, which is what we have. So we're good. All right, so what I've got is I've got x divided by x minus 5 times x minus 5. And then minus, okay, x minus 4. If I factor out my denominator here, I've got 2 times x minus 5. Okay, now let's think about this. Okay, if I want to get a common denominator between the two of these fractions, this one has an x minus 5. They have 2 x minus 5s. This one only has 1. So I need to first multiply this by an x minus 5. Okay. And then notice we're pretty close to having common denominators. Okay, we've got 2x minus 5s here, 2x minus 5s here. This one doesn't contain the 2. So the other thing that I need to do here is I need to multiply this by 2 over 2. Okay, so here's what I'm going to get. All right, and let's move this. Could do it here. So I'm going to get it 2x divided by 2 times x minus 5 times x minus 5 minus, let's put this all over one denominator, minus x minus 4, x minus 5. Okay, now I can't divide anything out yet because I need to combine my like terms up here. So let's move this all the way up here. I've got 2x minus x minus 4. Actually, hold on. All right, we're going to move that up there, but the first thing I'm going to do is multiply out x minus 4 times x minus 5. All right, I'm going to do the box method on that. X minus 4, x minus 5. So I've got x squared minus 4x minus 5x, and then positive 20. So combine my like terms here in the middle, I'm going to get negative 9x. Okay, so when I multiply this out, and I do need to multiply that out before I can combine my like terms here, what I'm going to get is I'm going to get 2x minus the quantity, x squared minus 9x plus 20 all over 2 times x minus 5 times x minus 5. Okay, now that I've done that, okay, I need to simplify this, and I'm going to distribute this negative up here. Okay, so I've got 2x minus x squared plus 9x minus 20 all over 2 times x minus 5 times x minus 5. Okay, now let's combine our like terms here and figure out what we get. So I got 2x and 9x. It's going to be 11x. So I got negative x squared plus 11x minus 20 all over 2 times x minus 5 times x minus 5. Okay, this would be reasonable, but it's not completely simplified. So, and after taking a second look, this is simplified, and this is our answer. Okay, I don't think we can factor the numerator. Perhaps we can, but this would be just fine to leave it like that. So, yeah, not too terrible. Okay, so all we're doing is just adding and subtracting fractions. Okay, but we have to know how to factor. We have to know how to get a common denominator with algebraic expressions. So this is, guys, this is not the easiest thing in the world. Okay. But it is, there are ways to do it. And the way to get better at this is by practicing, okay? And this is something that you will encounter for the remainder of the school year, okay? So we need to know it. All right, so let's take a look down here. And we want to simplify this fraction. This is a complex fraction, okay? This is what we call an incepted fraction, or a fraction within fractions. So what we have to do, I'm going to rewrite, what we want to do is turn this whole thing into one fraction. What I want you to see is that you have a fraction in your numerator and a denominator. And what we're going to do is we're going to turn those into one fraction. So let's do this. I'm going to rewrite this as 1 over x minus 3 over 2. Now, between 2 and x, I have a common denominator of 2x. So I'm going to multiply this one by 2 over 2. I'm going to multiply this by x over x. Okay. In my denominator here, I've got 1 over x plus 3 over 4. I'm going to multiply this one by 4 over 4 to get a common denominator. Multiply this by x over x. Okay. So what I then have is I then have 2 over 2x minus 3x over 2x. Okay, that's your numerator. Then your denominator is going to be 4 over 4x minus 3x over 4x. Okay, so now, all right, I want to turn this whole numerator into one fraction. So what I'm going to do is I'm going to do 2 minus 3x all over my common denominator, which is 2x. Okay, that's my numerator. We're going to divide that by 4 minus 3x all over 4x. Okay, that denominator. Now, when I have this, okay, this is where it gets a little tricky. I'm going to do 2 minus 3x over 2x divided by 4 minus 3x over 4x. Okay, now I have a division problem with two fractions. Now remember, to do division, we simply just multiply by the reciprocal. So I'm going to do 2 minus 3x over 2x times 4x divided by 4 minus 3x. Now what can divide out here are your x's, and then 4 divided by 2 is just going to be 2 over 1. So then what you have is you have this. You have 2 times 2 minus 3x over 4 minus 3x, because all this stuff divided out over here. All right, so now what you can do, you can leave it like this if you wanted to. You could distribute the 2. So you would have 4 minus 6x divided by 4 minus 3x. And you can't divide anything else out of here. Okay, the 4's don't divide out and the x's don't divide out. Okay, in order to divide out, you have to be multiplying. All right, let's take a look at the next one. All right, I've got 1 over x plus 7 minus 1 over x, and it's all divided by 7. So here, all right, what I got, I'm going to multiply this one by x over x, multiply this by x plus 7 over x plus 7. And the reason why I did that, guys, is because I have two fractions here that I need to turn into 1. Okay, so I need to subtract them together and get a common denominator. So now what I've got is I've got x over x times x plus 7 minus the quantity x plus 7 over x times x plus 7. All right, and this is all over 7. Okay, so now what I've got, let's combine my numerators. Okay, so I've got x minus the quantity x plus 7, all divided by x times x plus 7, all divided by 7. Okay, so this is my numerator. All right, let's distribute this negative here and see what we get. So I'm going to get x minus 7 all over x times x plus 7, all divided by 7. Okay, now if I do x minus x, okay, those are going to cancel out to 0. All right, so what you're left with is this. You're left with negative 7 over x times x plus 7. All right, that's your numerator, and then you're dividing that by 7. Okay, now what I'm going to do is this. Okay, I'm going to take negative 7 over x times x plus 7, and I'm going to divide that by 7 over 1. Okay, when I'm dividing by 7, I can write it as divide by 7 over 1. All right, so now what I want to do is I want to multiply by the reciprocal. So I'm going to get negative 7 over x times x plus 7 times 1 over 7. Okay, my 7's are going to divide out, and so then I'm left with negative 1 over x times x plus 7, and that's the answer that we're looking for. Okay, guys, this is a lot of steps. Okay, and you want to make sure you write small and you stay on the page. So this is not the easiest thing in the world. Okay, but you have some guidance here. Okay, I've gone through a lot of practice problems. Check your homework solutions when you do these other problems, and and so get started on your homework and get started on the other part where you need to record yourself. So good luck. Thanks a lot. Bye.